How can we make our society more silent? This is the daily business of my group at the University of Twente. In Silent Approach, we make airplanes more silent. My name is Kees Venner. I'm the chairman of the Engineering Fluid Dynamics group in the Faculty of Engineering Technology. Silent Approach is a collaborative project between the aircraft manufacturer Embraer, the University of Twente and my group Engineering Fluid Dynamics, and the Dutch Aerospace Lab, NLR, and the German Dutch Windtunnel, in which all four parties try to investigate the sources of aircraft noise in the landing configuration and try to come up with silent design alternatives.
When we started with this project, it was just an idea. So I started with one idea that I said, okay, let's work with airframe noise because this is something that is interesting for me. It's a research topic that I find really nice. Noise is one of the biggest problems that you have, and this is already recognized since the 50s when you had the first jet airplanes flying around. So the noise, it limits the growing of airports, it limits the expansion of the aviation. So noise is a real problem to our society.
You can listen better, but then there's a deviation of the flow, so the aerodynamic conditions are not exactly... What you need for these type of investigations is a good understanding of the aerodynamics of aircraft, and you need a good understanding of the sources of noise in the flow.
So those ideas to do this test come from the necessity of understanding the effect of the wind tunnel on the noise measurements that we do in aeroacoustics tests. So the wind tunnel also interferes in the measurements and brings some sort of uncertainties in those measurements. So if you do small scale wind tunnel tests at the University and NLR, then we do large wind tunnel tests at BMW, remove the uncertainty produced by the wind tunnel and then do better extrapolations to flight. So these wind tunnels, they have the right size and the right characteristics to do small wind tunnel tests here at the University of Twente and NLR, so it has a good added value. Then when you go to BMW, the cost of the hours there are much higher than in those wind tunnels. However, those wind tunnels, they have the right dimension to do industrial wind tunnel tests. And then from those industrial wind tunnel tests, you can make right extrapolations to flight.
My research is about investigating what is the influence of the wind tunnel test section and size on the generation of sound by a wing model. So this is a very unique wing model which we have in an academic wind tunnel, which you don't see very often. So this kind of setup is, you only normally see it at very large aerospace research institutes, but we've been able to develop the tools and the equipment that we need in order to get this model here and perform good academic research on it. And to be able to work with this model is really incredible, because when you stand in this tunnel when the flow is on, this wing generates a lot of noise and is actually almost equivalent to the amount of noise that the actual airplane is making. So to be able to work with this kind of setup it's really incredible. So my part here is mainly focused at the University of Twente to focus on this small scale test setup. And this is quite a unique setup where we can have both an open jet test section, a closed jet test section and a so-called hybrid test section with Kevlar walls, where all of these test sections, they either have aerodynamic performance, optimal aeroacoustic performance or a bit of both. We have now run the first test with this high lift device, which is quite special for this university because I've never tested such a device in this tunnel before. So we're really pushing it to the limits to see how far we can get with this model. So how we do this test is that we can set this model at different angles of attack, where we push the flow to the maximum velocity, where at every angle of attack and for different sets of velocity we can measure the noise and also the aerodynamics of the wing model.
In aircraft noise studies, often models are used and models are put in a wind tunnel. And the predictions from these models to real flight is very difficult because many phenomena related to the specifics of the wind tunnel play a role.
It's important to have good contacts with industry, to be relevant for society and to have connections all over the world. We have strong international partners and the partners in Brazil with Embraer, with ITA, belong to these strong partners. I'm exceedingly proud of this project. It combines various strengths. It combines something that we do together with one of our strategic partners. So this is an important aspect, that we have long-lasting relations with strong partners. The other part is also the direction of the research itself. The research has implications for society. It has to do with noise reduction. I lived myself various times in runways, so I know what it is firsthand. So it has implications for the way that people live, and this is also one way of engaging with society. The high-tech, human touch.
Within Silent Approach, I do research to wind tunnel measurement uncertainties. My role is important because I really look at the propagation effect of the sound. So that's one key aspect of a whole measurement, is the propagation of the sound from your source to your microphone array. It's of course key to have that, you need to know what happens, and you need to know that it also is reproducible.
Right now I'm really satisfied with the results. I'm really proud also of the results that we obtained. So for us it's the first time that we produced so much lift in our wind tunnel. So it's quite amazing to see how the wind tunnel is behaving with such large amount of lift production. So for us also it was a bit of a challenge, a bit of uncertainty in the beginning of the project if the wind tunnel was going to withstand so much lift production, mostly in the open test section configuration, that just brings special technical challenges for the measurement. However, so far we are really happy with the results that we obtained. We could obtain a maximum angle of attack higher than we were originally expecting, and therefore I'm really So I think that first of all, because we are a very nice research team here, where we can join the expertise with a very a warm heart research group. In this sense, we can produce very good measurements, very good results, very good scientific results here, together with this human touch that we need to have. So with human touch, where you work together with the company, you try to understand the needs of the company. We also expose what are the needs or what's on the stake on our side as well, and we make some very good agreements. So then I think this is a big differential here. We can put together this high-tech with this human touch in one research project.